Hi, in this video we're going to continue looking at precedence and short-circuiting for the Boolean operators. Now, as we saw, the Boolean operators not, and, or have a precedence order, and not has a higher precedence than and, which has a higher precedence than or. So let's take a look at the same example we saw in the lecture. Let's take a look at true or true and false. Well, when we run this, that evaluates to true. Now let's see what actually happened. What actually happened is that and has a higher precedence than or. So it is going to get evaluated first. And so in fact what we have is really true or, and then first calculate true and false. And that's how we get true. Now if we had done that differently, and we're going to force now or to be evaluated first, and then we'll have the and evaluated, then what's going to happen is that true or true is true, and true and false is false. So when we don't have the parentheses, then the and gets executed first, gets evaluated first with its two operands, which are true and false. Whereas with the parentheses, well, that takes higher precedence, so we have to evaluate what's inside the parentheses first, which is the or. So we do true or true first, and then we and it with false. So it does make a difference. So these two statements here are equivalent. And yes, it's true that they're equivalent. It's true that, yeah, you can probably make out what this does. And if you read it, and you remember about the precedence, then you'll say, oh, okay, it's going to do the and first. But it is far clearer to somebody reading code that this is happening. And so I would really suggest that you write it this way. It really doesn't cost anything to add those couple of parentheses in there. And it will keep Bob happy. I can't bring up Bob in here. I only have it on my slides, but Bob would be happy right here. He wouldn't be too happy with this one. So just a suggestion. And of course, as your Boolean expressions get more complex, then you really want to start putting in the parentheses. Plus, there might be cases where you have to put the parentheses in. All right, so the next thing I want to look at is short-circuiting. And short-circuiting is really what happens when you have, let's say, a true or y. Well, when you have true or y, that will always return true, no matter what y is. And if we have false and y, this will always return false, no matter what y is. Right? So what happens is that if we have an expression where the left operand evaluates to true and it's getting ORed with something else, Python will not evaluate y. Now, y could be just a Boolean number, or it could be a whole expression, or even a function call that returns a Boolean, or a function call that returns an object that has obviously a truth value associated with it. So that's the whole deal, right? Is that we don't have to evaluate necessarily both operands of an or an and in certain cases. So let's take a look at an example. We saw a couple in the video in the lecture, but I'll do a slightly different one here. Let's do a equals 10 and b equals 2. And we want to run some code only if a is at least 2 times b. So we might write something like this. If a divided by b is greater than 2, then we might say, print a is at least twice b. And if it's not, we don't want to do anything. So kind of a silly example, or a silly consequence of the if statement, but whatever. That works for our illustration. So if we run that, well, we get that a is at least twice b. Yeah, because 10 divided by 2 is 5. A is actually 5 times larger than b, or 5 times the size of b. But what happens if we make b equal to 0? Well, let's try it out, right? What do you think is going to happen? Well, we're dividing by 0, so that's going to create an issue, and it generally does if you try and divide by 0. So we're probably going to want to try and avoid that problem. And one way of doing it is to say if b is greater than 0 and a divided by b is greater than 2, we can certainly do it this way. That is one way of doing it. Now, of course, we could even use nested if statements. If we wanted to, we could do something like this. I'll write it out. Okay, So we have that. I need to indent it, and I want to make sure that A is non-zero and B is 0. So let's run that, and we get nothing. Yeah, because B is equal to 0. It's not greater than 0. Okay, so we could do it this way, but because of short-circuiting, we can just simply do this. If 0 and. So if B is greater than 0 and A over B is greater than 2, and no errors, no problem. That's because we short-circuited. Since B greater than 0 was false, Python didn't need to evaluate the right operand. It didn't need to evaluate this expression. It knew that whatever this was, it was going to be false. So that's one way of doing it. But of course, truth values, right? B is a number, and if it's 0, it's going to have an associated truth value of false. So I don't even need to do this. I can just say if B and A divided by B is greater than 2. That's all I need to do, right? So this will work exactly the same way because B is truthy or falsy. Now if B is 0, it's falsy. And again, the short circuit means that this is not going to get evaluated. And fair enough, it doesn't happen. However, if B, let's say, is 1, then we get that A is at least twice B. That works just fine. Now we could even have the case in here where B is none, right? This will still work. If we do this, we might have a little bit of an issue, right? Because the greater than is not supported for none. Well, yeah, none isn't a number. It's just kind of nothing, right? So this is why B is actually even, if B is even a better syntax, because we don't have to worry about when the cases where B can be none. So go back to this example, everything works just fine. All right, so that's one example of using short circuit evaluation, as well as combining it with truthiness of objects in Python. So let's take a look at another example. And for this one, the first thing I'm going to do is import the string module. So we can look at the help on the string module. It's really a very, very useful module. Doesn't do much, but it's quite useful. It's a collection of string constants, right? And so you have some string constants like white space, ASCII lowercase, ASCII uppercase, digits, hex digits. And what it means is that it just is a predefined list of ASCII letters, ASCII characters that fall into certain categories. Let's say you want to test if a string, a character, is, let's say, a lowercase character. Well, all you could do, let's say you have A equals C, you might say is A in, and we'll do string dot. Now we're looking for an uppercase ASCII character, so we might do this. See, quite useful. It returns false. Now, how did that work? Well, let's look at what ASCII uppercase actually is. And as you can see, it's just a string with all the uppercase characters, A through Z. If we do string dot digits, then we just get the digits from 0 to 9, right? And if we do ASCII letters, then we get all the lowercase and uppercase letters, and so on. So it's just a quite useful little library that we can use that has some predefined string constants. So in this case, we're going to go back to that example we saw in the video, and we're just going to test to see if the first character of a string that we get back from a database actually starts with a number or not. And we don't want that, so we might want to say, hey, you know, a name that starts with a number is not allowed. Something like that. So I'm going to simulate, of course, opening a database connection and retrieving it. And we're going to start with maybe the name. Let's say the name is Bob. Okay, so we'll bring Bob back this way. And we might do this. Say if name 0 in string digits, right? So if the first character of name is in digits, then what do we want to do? Well, we might want to say print name cannot start with a digit. Okay, so when we run this, no problem. If we start with a digit, it tells us name cannot start with a digit. So that's working just fine. But what happens when name is an empty string? well, we get an error. Why? Because, well, we're trying to return the first character of that string, but it's an empty string. There is no first character. So our index in the string is out of range. So then, okay, let's fix that. Let's say len of name must be greater than 0 and. Okay, so let's do that. And now that works, right? But first of all, we don't have to put the greater than 0. Len of name is what? It's going to be a number. If the length of that string is 0, then it's going to return 0, and 0 is falsy. If the length of the string is greater than 0, it's going to return some number that's non-zero, and that is truthy. So technically, we don't even have to put this in here. We can just put if len name. And when we run that, it works just fine. But remember what we discussed in a previous video as well for sequence types. Sequence types will actually return the length when you look at the truthiness. So you don't have to look at the length. You can just look at name itself. That will actually return the length, right, in terms of the truth value associated with name. Right? If we take a look at an example here, name equals, let's say, ABC, and we look at bool of name, well, that's going to call the len method that's on that string, which is going to be 3, and so that's going to be truthy. But if the string is empty, then it's going to return false because the length is 0, and that's falsy. Okay, so we don't have to actually, say len name greater than 0. We can just run it this way. This works just fine. Now, in fact, if we had kept this len name greater than 0, which works okay, I mean, that's fine. But let's say that name was not even defined. Let's say that name came back from the database as a null. Then this means usually that name will become a none in Python. And if we do that, well, we have an error again. Because why? Well, none doesn't have a len method, right? There is no length to none. So now we would have to say if name is not none and len name is greater than 0 and name 0 is in string digits. Now that will work because, again, we're short-circuiting. We're short-circuiting, well, name is not none, well, it is none. So name is not none is false. And we have and. So these two are getting short-circuited. There's no need to even evaluate them. So this doesn't get evaluated and this doesn't get evaluated. But of course, we can shorten this whole thing here because if none is falsy, a length of an empty string is falsy, so we can just basically collapse it down to this single thing. Because if name is not none and name has a length, has a certain number of characters in it, has a non-zero length, then this will be truthy. Any other combination of that, it will be falsy. If name is none, it will be falsy. If name is not none, but it is a string with no characters, then it will also be falsy. Okay, so this works equally well. And we'll see more examples of short-circuiting as we write more complex code as we get further into this course. But for now, just be aware that it's really useful for a lot of different things. All right, thanks for watching, and I'll see you in the next video.